This is just for anybody who missed the meeting call, whatever, that we had earlier. Um, I know a couple of people in Higgins didn't get a chance to get on, and it was only Higgins, so obviously Robinson, we didn't do that. I've set everybody up on Teams now, so I suppose my plan at the moment, I thought the call worked really, really well. I should say, like, apologies for the short notice, but it was literally just to see if it would work. I didn't know if it was going to be a nightmare. I didn't know if everybody was going to be talking at the same time. It seemed to work quite well. I do, like, I think it could work. So I suppose what I'm proposing is I'll continue to do what I've been doing, making the videos, putting them up, giving you your assignment, which is due for your next class. And if there's something that's causing, like, so if you're not sure about something, either send me an email or write it in Schoology and just say, like, just not sure about that. If it's something I can answer easily and you're the only one with the issue, I'll answer it. If, like, this work, there was quite a few people in Higgins who got on to me to say, like, oh no, having massive problems with this, then that's fine. We can organise one of those group chats, because, like I said, it worked well. So anyway, the content that seemed to be causing the problem was this question here. So a couple of things that I didn't tell you in the video. So this thing here, the atomic number. The atomic number is the identifier. Okay, so that's how you know which element you're looking for. Okay, the mass number can change. Okay, the mass number does not have to match what's in the periodic table, and I'll explain why in a second. So the mass number is not going to be an identifier because it can change, but the atomic number never changes. So the atomic number is how you identify which element you're talking about. So if we're talking here in the first one with an atomic number of 6, we go up here and we find an atomic number of 6 that we're talking about carbon. Okay, now as some people pointed out, carbon in the periodic table has a mass number of 12. Okay, whereas down here they say the mass number is 13. Okay, and this is why you can't use mass number to find an element. In certain situations, when the mass number is different, what you have is what's called an isotope. Can I spell it? Isotope. Okay, so what we have is this here is an isotope of carbon, and an isotope is when the atomic number is the same, but the mass number, God, I can't spell today, the mass number is different. Okay, so this is definitely carbon, and we know it's definitely carbon because of the 6. We have identified the fact that carbon in its natural state in the periodic table should be mass number 12. The one we're talking about here isn't, so we know that it's still carbon, but it's an isotope of carbon. Okay, now how many protons? So carbon, the one we're talking about here, the isotope, is carbon 613. So this number here, the atomic number, is the number of protons. Yeah, to get the number of neutrons, we do the big number minus the little number, so mass minus atomic, and we get 7, and that's how many neutrons there are. And then however many protons there are, we must have the same amount of electrons. So the protons and the electrons must match. So I can fill this in now. Number of protons is 6. Number of neutrons, I subtracted and got 7. Number of electrons is 6. The name of the element, which we found out looking at the atomic number, is carbon, and the symbol is C. Okay? So the next one down, it doesn't give us the atomic number, and I said that the atomic number is the identifier. So what do you do if you're not given the atomic number? But look here, we are given the number of protons. Okay, and if you look at my little example over here, the number of protons is the same as the atomic number, and we should also note that it's also the same as the number of electrons. So very important that the number of protons is the same as the number of electrons, which is the same as the atomic number. So the fact that I know that there's 12 protons means I know the atomic number. It's 12. Okay, so go up here, 7, 8, 9, 10, 11. There's 12 there. So it's magnesium. So we know that it's Mg, and Mg is magnesium. Just about fit that in. So we're looking at magnesium. They want 12 as the atomic number and 24 as the mass number. And from there, you should be able to figure out 12 protons means it must be 12 electrons. And then if you do 24, take away 12, you get 12, and that's your neutrons. Yeah? So hopefully that helps. That was basically what was discussed on the chat this morning. I suppose let me know if you have any more questions. All right.